Hi everybody, my name is Jimmy Carroll. I'm the Vice President of Operations at Tech B2B Marketing, and I'm here for a special edition of the Manufacturing Matters podcast. I have the pleasure of being joined by my colleague and friend Winn Hardin, and I have a great group here to discuss all things robotics today, and I'd like to introduce SK Gupta from GrayMatter Robotics, Josh Cloer from Mujin, Suzy Teele from the ARM Institute, and Juan Aparicio from Reshape Automation. Thank you all so much for joining, really appreciate it, especially here on a Sunday, taking the time out of your day. It's our pleasure to have you. So I'll jump in right away and ask a question that you've all been asked before and have undoubtedly answered many times. But is the world finally starting to understand that robots don't steal jobs, but they actually create them, and they create more profitable companies and create new jobs, new interesting jobs. And anyone but Suzy, if you'd like to start.
Yeah. I would say not as much as we would like.
Yeah.
There still is a stigma. We were talking about this earlier today, what happened in Los Angeles with the dock workers, right? Mm-hmm. So there's still, the stigma still surrounds it. And what we had a good discussion earlier today was about maybe taking away from jobs and more focusing on increased productivity, right? And so not making that a competition between a robot and a job, but how can robots help people be more effective, how they can be safer, how they can have potentially more enjoyable jobs. If we can turn the conversation more in that direction, I think that will help a lot, because I've been doing this for 8 years, that fear still exists, right? So.
Yeah, I would completely agree with that. I think to the layperson out there that doesn't think about robotics every day and see robotics every day, or even think inside of the manufacturing space, they still have this idea that robots are taking jobs. It's not just robots, but RPA type automation and computers all over the place, right? Automation is taking jobs, and I think what they don't understand and what they need to learn more about is the labor crisis that we are really kind of on path towards. And I think Japan is a great example for us to look at and to see that, hey, if we are on that trend, we need to go ahead and take steps today to make sure that we don't get to a place to where we aren't able to actually get the things to people, when they're buying stuff online and that kind of thing, or even just the everyday interactions that you might have if we end up with a labor crisis similar to that. So I think that's more of the message that we need to get out there into the world.
Yes. Great.
Well, people are generally really, really good at anticipating problems coming down the road and preparing themselves in advance. That was all sarcasm. Just for the record. I wish that was the case. So can you guys talk a little bit about artificial intelligence? Always the big topic, right? And we've typically applied it more to machine vision, which is one of the technologies that we'll deal with quite often. But when it comes to robotics, talk to us about AI and robotics. Juan, do you want to kick us off?
Yes, definitely a hot topic. A lot of signal to noise, similar to robots. What can AI do? What can AI don't do? Right.
Right.
It's very interesting how, if we think about AI a few years ago, we will all think that actually it will enhance robots and replace the manual tasks, right? The blue collar jobs. But in reality, what we are seeing is actually something different, right? What the technology that is really changing the game here, LLMs. It's more replacing the entry jobs of the white collar jobs, right? The junior analyst kind of jobs. Right? The back office workflows can now be automated, which is very interesting. While things like an electrician that comes to my home, it's not going to be automated, probably in my lifetime, right? And same things that require dexterity, that require autonomy, that require different ways of thinking, right? This is still humans will outperform, and everything that is manual, right? Very counterintuitive, if you want, from the general purpose. But to your point also, what AI can do, it has really revolutionized machine vision. Start to make a dent in dexterity too, for tasks where the output, even if it goes wrong, doesn't really matter, right? Like beam picking. It's a perfect application for AI, because even if you don't...
It seems like it, because you need that adjustable on-robot path correction, right? That seems to be a critical part of it,
exactly.
Which has always been the challenge with bin picking.
But you can recover. Now the problem starts to be, what if you make a bad decision, like the algorithm, because it's stochastic, what will happen if the decision is not the right one? Then you don't have that determinism that you used to have with automation.
Right.
So these are questions that we all practitioners in this industry need to start asking ourselves.
SK, do you have
Yeah, I
some
mean,
insight?
we are seeing many, many new ways in which AI is being used for robotics.
Right.
So one field that used to be there, learning from demonstration or imitation learning, where idea was that human will do a demonstration and robot can learn from it.
Right.
So previous generation of AI technology was showing significant limits to how generalization or how generalized the solution could be from a limited number of demos.
Right.
But recent things that we are beginning to see with more generative AI type of techniques, such as diffusion models, generalization is dramatically better. So you can actually show very few demos, and you can actually then learn significantly more generalizable solution.
Right.
We did talk about adaptability, so it allows robot, when it's doing processing or motion, react in real time to whatever is going on.
Right.
You have also seen now generative AI being used to synthesize test cases so that you can test the robot, better ensure, how reliable the solution is. So we are
Yeah.
seeing that. Beyond machine vision, again, there are many more modalities. You have force sensing, you have tactile sensing,
Yep.
You have acoustic signals coming in. So all of those basically are benefiting again from, your cross attention transformer technology, right, which is the backbone of your LLM. So all of that is tremendously beginning to benefit the perception pipelines. And LLM themselves are now being used to encode some common sense knowledge for the robot, right? So some of the very hard-coded task planner, you can start replacing them with LLM type of engine. So in the field of robotics, we're beginning to see many of these new generation AI technologies beginning to play a really important role.
When we talk about LLMs, how close are we to voice programming? I've started to hear people, make mentions of it. I'm thinking, I think Neuros was talking a little bit about it. But
Yeah, I can start from what I've
Please.
seen in the kind of conversations with LLMs myself. It's getting much and much better. I think there's been actually tremendous gains over the past few months even
Right.
with some of the things that have come out in terms of voice recognition and being able to talk naturally to it and comprehension of what you're saying regardless of your dialect or accent or language that you're speaking. I think it's gotten a lot better.
I know,
I
Siri
think-
still hates me, so I don't know. But
I think the challenge there is more, there's still a big leap to take inside of the robotics area. In general, we're still reliant on very legacy controls systems, and I think that's something that needs to be changed over the course of time before you can get there. You have to have an understanding of what it is that you're trying to do, what is the surroundings that may impact your goals, and for you to be able to talk to something and tell it to achieve a task, it has to understand what's going on around it, right? So I think there's
Right.
still a lot to do in that regard in terms of building intelligence into our systems. And overall, that's what's going to provide more accessibility to robotics in the end. And I think you've actually got a great panel here to talk about the building more access for robotics. That's, I think, the kind of the core mission of everyone on this panel today. So I think that's really where we should focus from my perspective, is how do we allow more people to take robotics and do something valuable with it inside of their various manufacturing workflows.
Right,
Yeah.
right. And go
I
ahead,
think
Juan.
the interesting thing also about programming a robot, right, is that the trend of making it easier to program with no-code tools has been going on for a while. You still need to know what you want to do, right? With that, it's never the case of the simple examples of, okay, robot, please pick up the blue ball and put it in a bin, right? There are more complicated things going on in manufacturing, and it highlights more that you need to know more about the process.
Yeah.
And then probably relax the individual. How do you program this robot specifically? That will be less important, but still having the notion of what you are trying to do, how variable is your process, what are the limitations of this automation system, the mechanical limitations, right? That's still going to be the hardest part, while the programming will still be more and more simple.
I would say, we talk about people's fear of robotics stealing jobs. The fear of AI is tenfold, right?
Oh, yeah.
Because they can't even define it or understand it.
Yeah.
With a robot, you can see it, so you can get a sense of physicality of what it is. But but you can't see AI, right? And so what we're finding is there's a lot of organizations that are just don't even know how to start to comprehend how they could use the benefits of AI in their environment. They don't understand very basic things like there's software and there's data, right? And they have to find a way to work together. And you have to be good at collecting data or finding the data in order to be able to make this stuff work. And so many small manufacturers are not good at those types of things, right?
No.
They don't have sophisticated ERP systems or other systems, and they're doing the analytics that you need in order to be able to train the models to do the things that you want them to do, right? And so it's even harder for these manufacturers who are trying to figure out how to bring robotics in to now try to lay AI-enabled robotics on top of that.
It's funny because it seems like the speed of change is, and I know we say this a lot in technology sectors, but that it's literally exponentially growing. I mean, the AI adoption we've been talking about deep learning, AI for 20 years, neural networks for 20 plus years, right? And very little happened, and then suddenly about, what, 7, 8 years ago, there seemed to be an explosion. I'm thinking primarily in industrial. There's been smart agent tools working for data mining in a lot of different applications, but it blows my mind how fast things are going, and it seems to be a through message on almost everything we've talked about so far, is that the base models are such a key point. I mean, as when we talk about doing demonstration and programming by demonstration, more complex assembly tasks, maybe using more complex end effectors or whatever the case is, the ability to show fewer demos, SK, right, that's directly related to the quality of the foundational model. What in that contextual component you're talking about, right? How much the robot can understand its environment and all the objects in it and how they interact. So Suzy, it just seems like we won't have to wait long before AI will actually evolve, and I don't mean in general purpose machine, artificial intelligence, but just it seems like in 5 years I can only imagine how much power industrial consumers are going to be using, what AI is going to be able to deliver for them.
I would say yes if the data's there. And
Right.
if we could either create the models, we can create the data ourselves, or whether we can extract the data.
Yeah.
In the work that we've done at the ARM Institute, that's one of the biggest challenges that we see. The software's there, it's great, right? It does what we need it to do.
Yeah.
But how do we get data on the scale where we can actually have an impact on multiple manufacturers, right? That's one of the challenges that actually SK and Juan are helping us solve at the ARM Institute, is trying to determine how to connect all the dots, right? So that there is practical applications for AI that make a lot of sense in a manufacturing environment.
Yeah, but also just I want to put a little cautious note, right, on that, right? Because see, large generative AI, the one which we are seeing right now,
Yeah.
which is doing quite well, and perhaps reaching 99.5% accuracy. But most of the manufacturing tasks, you're not going to be happy with 99.5% accuracy. You're not likely to be happy with 99.99% accuracy. Remember, we are seeing sign of saturation in large language model with basically billions of data, basically used, right?
Right.
And they are saturating at 99.5% accuracy. Now, it's unlikely, first of all, that you're going to have billions of data pieces in manufacturing.
Right.
So if we purely extrapolate that what we have seen as of today, that 5 years down the road, for some application, sure, for some application, given the right context, given the right bounding boxes around the problem, right?
Right.
AI will do spectacularly well, but there'll be a whole sets of problems where, at least with the current AI paradigm, right, where you throw more data and squeeze out more efficient, basically more reliability or more or reduce the error rate,
Right.
model is simply not going to scale. In manufacturing, it's just not going to scale.
That is
There is
interesting
no
point.
way you're going to get to 99.999%. In my lifetime, with the way if we just acquire the data and basically train the model, it's not going to happen. So good news is that we will see a whole bunch of really great things in the next 5 years,
Yeah.
but there will be some tough problems,
Yeah.
which I mean, at least the current generation of AI and anything that I know of is not likely to solve in 5 years either, basically. Right?
That's good. We all have job security.
I'm much more optimistic about AI copilots than pilots, right?
Right,
Really
yeah.
enhancing the capabilities of humans, in this case, of programmers. We are even using it ourselves. We have our own AI software engineers that are agents, that write code. They don't know about software engineering. They know about coding, right? So they will create a very good code. This is the first amazing UI, but then all the back end, the best practices, you still have to do it. But it has accelerated our software development by 10x at least, right?
Yeah.
It's this copilot, it's this enhancement of human capabilities that we are experiencing with this technology.
Outstanding. Yeah,
And I
that's a
think
good
it
point.
builds on both what you both said. If we look back the history of robots, the industrial robots took off because they could do the same task repeatedly, right? But cobots need to be more, people want them to be more customizable, more personalizable, more specific to their own environment. And we see that's a harder problem to solve. We're running in, we'll go through the same evolution with AI, where there'll be certain AI models that fit that industrial mode, right, because they're a repeatable process. But
Right.
so many of US manufacturers are custom manufacturer shops, right? They get an order and they have to change their process to build a product for some certain person that's different from the thing that they're doing the next day. And so how you get, good 99.99999% in an environment like that is a hard problem to solve. It's worth trying to solve, but it's a hard problem to solve.
Absolutely.
Oh, and just talking about LLMs in general, it's interesting. There are some big companies that are using, like Juan, what you were saying, like using it to do certain coding tasks or whatever. But I've repeated this story, and SK, I maybe even said it to you when we did a separate podcast together a while ago. But there's a gentleman I did a podcast with over the last summer, and he was a director of AI at a systems integration company, and he said, we're having great success with LLMs, but there's still hallucinations that are causing issues. He said, I asked ChatGPT, and this was over the summer, and to your point, Josh, like maybe, ChatGPT has made some improvements, and but he said, tell me the names of Snow White's 7 or 13 dwarves. So they gave the 7 names and then made up the rest. So it's just like, that sounded similar. So there's still like little problems like that need to be worked out for it to add full,
That
full
could be a
value.
new Disney movie. We are in Orlando.
Sleepy, grumpy, Juan, Carroll.
The difficulty of hallucination is that it's not a bug, it's a feature, right? It's something that why LLMs are good and are achieved this 99 is because they can hallucinate.
Right.
And then that is a great feature for it. But when it comes to the physical world, then we cannot allow this kind of hallucination because then things can break, right? I think I really like, and Rodney Brooks will be one of the speakers here, but what he mentions about that two things have to be true for any AI application out there, I think it's still true. Like either there is a human in the loop or the risk of failure is low. Right? But if the risk of failure is high and there is no human in the loop, there are not many AI systems out there, right? Even in Waymos, when something happens, there is a person in the back that can take over, right?
Yeah.
That's very important. Right?
Yep, and we've got all the Tesla YouTube videos to prove it.
Yeah.
That's when you take the human in the loop out of the connection. So we talked a little bit about AI in terms of helping spread adoption of robotics, but are there, beyond the standard ease of use, and you talked about optimization and customization of cobots specifically in those, are there other things that robotic companies that are doing right now that are helping to spread the adoption of this robotic technology, whether it's AMR or whether it's cobot, traditional, industrial?
So basically, one of the ways which robotics always, seems to help.
You are the future. Across industries, you are bringing people together from all backgrounds and skill levels to unlock the potential of automation. To make higher quality products with unprecedented precision. To deliver what people need when and where they need it. Forging safer, higher paying careers for those in the industry now and for generations to come. Your technologies are saving lives, helping to feed millions of people around the globe, creating a greener future while sustaining the heart of our manufacturing industry. Over the last year, you've driven innovation, deployed new technologies, and helped us build the largest Automate show ever. There are now a record number of you, our A3 members, and you inspire us with your hard work and commitment to excellence. You are the Association for Advancing Automation.
Is that it can improve your process dramatically, right? Over human operations, right?
Right.
So in terms of speed, for example, if you're doing sanding, a robot can sand 4 times faster than a human can, right? So obviously you get 4 times the throughput than if a human is sanding it, right?
Right.
So there's a huge benefit to then robot doing it, right? And the reason for it is robot can move much faster and robot can apply significantly higher force, and you can spin the tool much faster in robot's hand than what you can do in a human's hand, right?
Right.
So once you take away humans' constraint, then robot can, in many applications, do much, much faster, right? Second thing is quality, right? So you can deliver quality which is going to be, again, significantly better than what human can deliver, right?
Right.
So adoption of basically then AI-powered robot offers those two benefits. If you get successful, then you get dramatically better throughput and you get dramatically better quality, right? And those then become business drivers basically for adapting it. Now the challenge has been in high mix, you need the right kind of AI to power the robotics so that you can have those gains, right? But without that, if you're gonna then come back and demand that a human programs the robot, then obviously this is not gonna work.
Right.
I mean, the other trend too, to your point, algorithms are getting better for some applications, and things that were impossible, like doing sanding in a high mix, low volume, now is possible for thanks to companies like GrayMatter. Same thing with some applications in machine vision that used to be extremely hard with rule-based. Now with AI, they are possible. At the end of the day, it's also another trends that are less sexy, but that matter a lot because it's all about ROI, is that costs are going down, right? And if there is more competition, more systems, more standardization, right now, if you want a palletizer, there are many options that you can choose. That's driving the cost down, and for a lot of customers, this is now this makes sense, economic sense. Because even if the applications were amazing, it's all about the ROI. And the way that ROI is calculated going full circle is not considering all the benefits that SK mentioned. It's typically how many people do I replace? And they don't account for every other benefits that is probably 2x what the salary is.
So the building up on what Juan said and connect, to give you an example of robotics and machine vision and sustainability, right? So basically what happens right now when humans do sanding, so as the sandpaper start wearing out, to compensate for it, you have to apply more force, right?
Right.
As a human, nobody wants to do that. So you're better off just tossing the sandpaper after a little bit of use, right?
Right.
Now, if you can get robot to do it, and then you can have machine vision, which can monitor. A machine vision problem is super hard because you have these sandpaper wear detection pattern that you're doing it. So you can do that with the modern machine vision techniques. So if you can monitor it, you can figure it out exactly how much life is left and how much the sandpaper has worn out. And robot can compensate by applying more pressure and adjusting the velocity. So if you have an adaptive, robot, AI-powered machine vision, it turns out that you can actually reduce your, basically sandpaper consumption on a sanding line by 40%. So that has now huge sustainability benefit as well because you're sending less sandpaper to landfills. And also, if you are using expensive sandpaper, that was also a huge saving, right? Which when people were doing traditional ROI calculation and seeing how many humans are replacing, that wasn't anybody's radar screen, right? When people start deploying it, they say, why are we not ordering that much sandpaper as we were ordering before, right? That's when they're discovering, oh, robot doesn't need that much sandpaper. Then the question is, why not? Because robot is really optimizing it, right?
Yeah, and since you're tracking everything with force application
Exactly.
and speed,
Right.
rotation,
Yeah,
everything
yeah,
else,
yeah,
you can
absolutely.
have a predictive model, right? To predict when it's
Another
gonna-
angle to look at is just the amount of involvement now that you see from robotics companies or suppliers in the automation industry with robotics competitions. Another way to solve this problem is to make people feel more comfortable working with robots, right, at an
Yeah.
earlier age.
Yeah.
And so what I've been encouraged to see is the more active participation by the industry as a whole in FIRST Robotics and VEX Robotics and people volunteering and working with these students, thousands of teams across the United States right now. And so another way to solve the problem beyond what's really important, what SK and Juan talked about, which is how well these work, is letting people know that they can use them, right? They're not intimidating, they're not scary. If a bunch of 14-year-olds can get together and build a robot to do something, then maybe I can do that kind of thing too in my job.
Yeah, I think that's another trend that you'll see with AI as well in terms of helping the operation use the very expensive, in their mind, robotic system that they just got, right? It's usually non-skilled labor that has to go and figure out, okay, something went wrong, what do I do? I'm not sure I've seen this yet, but I think we will see this in terms of trends. In the software world, you see a lot of these co-pilots where you can kind of directly ask things inside of the software and like a CRM, and you can say, hey, I've got a new deal, here it is, and then they'll just put it into the system for you. Well, you'll see this in robotics as well in the future. When we have more software-enabled robotics, you can go in and say, oh, there's an error. Well, what does that error mean? And you can have this kind of conversation with the system, right? So I think that's going to be coming up as a trend for AI and robotics as well to help the user experience within the robotic systems.
Especially, in words they understand, right?
Exactly.
Yeah, that's fantastic.
We
Excellent
already
point.
have in our system PHM integrated into it.
That's great.
Every time, anytime robot is entered the fault mode, it will give you hypothesis as to why it went into that fault mode.
Exactly.
So yeah.
Over the last several years, and there's some good examples of the companies that you guys represent on here, but over the last few years, there's been sort of a rise, at least my perception is there's been a rise in the availability of these application-specific, like purpose-built systems that are used for depalletizing or sanding, grinding, whatever. What's led to this, do you think, and what impact does it have on users? And then part two of that is like, could you see? I mean, Suzy, you mentioned cobots earlier, and that's a good, I'm glad that you did, because part of this I'm thinking is like a lot of these systems are leveraging cobots. Will that help the smaller and medium-sized enterprise adopt automation faster?
I'd say there's one factor, and that's lack of skilled labor. That's pretty much everything that we see is pretty much driving an interest in bringing robotics in. So we have a couple of factors that are, again, you mentioned Japan. So what's happening here? Our manufacturing workforce is aging. Its average age is 55 and above, right? Younger people are having less children. And that's actually a worldwide trend that they think it's permanent. It's not temporary. They see that in Japan already, right? There are a lot of single women. There are women that are choosing not to have children that are focusing on their careers. And so what we have is a shrinking labor pool in the United States. And when we look at and talk to the manufacturers in our environments, the number one thing we hear is, gee, I would like to bring a robot in if I can find somebody to actually manage it after the systems integrator or the supplier has left. Right. And so I would say that that's probably the biggest limitation that we have in the United States, which is why it's important that we get younger people exposed to advanced manufacturing technologies earlier in their learning cycle. What we found is that you have to, about 5th grade, have to let kids know that they can be a doctor or a lawyer or a teacher or a manufacturer, right? And we don't do a very good job of that in the United States.
Absolutely.
I think these are the two sides of the coin, right? Teaching them or exposing them to manufacturing, to produce things, to different processes, and then automation, right? I will say that one of the reasons why this specialization exists is that you need to be very specialized in the process. The process becomes even more important, knowing about the process and knowing about the robots, right? The same robot, the same white, yellow, orange robot can be doing depal or can be doing sanding, with some differences. But it's the knowledge of the industry that you can speak the same language what differentiates one company versus other, right? If you want to do welding, you have to do it very, very well. You want to do tandem. There are few applications that are around that, but it requires a specialization. And also that specialization in the go-to-market and in the technology. Same thing for, in your case, for the end of line, right?
100%. I think in terms of the purpose-built robotics, I think that's where I see there's a lot of talk about AI. I think it's really more about the applicable intelligence in different buckets in different areas of the robotics environment that's creating these purpose-driven things. So it's been, for material handling, it's been machine vision that's primarily driven the capability of doing things like mixed palletizing, right? Picking anything that can just show up on a pallet, where you have to really understand what's going on with a combination of different sensory technologies and a combination of different algorithms. It's not just machine learning that's making that possible. It's a lot of different things coming together. So I think that's the hype is there with AI, but it's more than just the artificial intelligence that brings these things to life.
Yeah, so, yep.
I was going to say, just to be a little bit polemic here, because otherwise it will be boring. There is no such a thing as a general purpose robot, right? Like this, when a humanoid portrays itself as a general purpose, that doesn't make sense. Like even humans, we are not general purpose, right? We do a few things very well, and we are going to see that, right? That in most cases, the application, the best application, or the best form factor for solving a specific application will not be a humanoid, right? It will be something else that is specifically built to solve that application. That's how you get this 4, 5x, 10x speed over a human.
Yeah, I mean, so decisions, to embrace new technology get made based upon usability and ROI, right? Am I going to get my ROI, which I'm hoping for, and how easy this is going to be to use this technology, right? Now, spatial purpose built robot often deliver very good ROI, right? Because they can run much faster, they can give you significantly better quality, and therefore you can make an ROI case. And obviously, sometimes the penalties on usability, right? So the thing is that, okay, then you have to figure it out. What training do I use? How do I get the right kind of workforce, right? But if ROI argument is there, people are likely to figure it out, the usability piece, if the ROI argument is really compelling.
Right.
On the other hand, if you approach the problem from the other way, where robot is highly, highly usable, right? A child can use it, but your ROI is not favorable, it's a toy at that point, right? Nobody's gonna deploy it, right?
Right.
So one has to think about, from that perspective, that if a very specialized robot can deliver you spectacular performance, right? Then chances are that you will figure it out how to utilize it, because business benefit is going to be so great. Therefore, you'll figure it out, right? So.
Yeah. And people tend to think in factors of, I've got a problem to fix. They don't say, I want to automate my whole manufacturing plant. They say, I'm not getting this product out the door fast enough, or I'm having problems finding people to be able to work in the a certain area of, because there's chemicals, or it's, it's sanding, and that's a very, very difficult job to do. So we're oriented to think towards, what can I get that will solve this one problem for me right now that meets the ROI factors and the usability factors. And I always say, like, when you think you're having a heart attack, you don't want a GP, you want a cardiologist, right? And so it's kind of the same concept. Like, you want the specialist that knows how to solve that particular problem that you have in your environment, which is why you have special purpose systems. Ultimately, you want them all to talk to each other, right? But for now, you want to solve that one problem that's holding up your production process.
Gotcha. So you mentioned Humanoid a little bit ago, so I'm really curious to get this panel's input. And I was at the Humanoid Robotics Conference earlier this year. It was really cool. We don't have a standard in place yet for it, right, in terms of safety standards. But where do you guys come on that? And maybe compare and contrast that to AMR with arm-on, movable pedestal, mobile systems like that. And talk a little bit about both of those.
Yeah, I think Juan hit the nail on the head. For me, it's there's no such thing as a general purpose robot, and that's really what we're trying to accomplish with a humanoid. Is I think one of the challenges that I see on my side, in the distribution side of manufacturing, is you have a lot of companies that have built these massive distribution centers all around a human, and we think that we're going to make a robot that is, looks like and does things like a human, and then it just goes into those types of environments. Instead of thinking, why don't we change the way the infrastructure looks to match what a robot is capable of,
Right.
or even a new form factor that's even more powerful and capable than the current robots that are out there today. So I think that humanoids over time will evolve to do things that are really, really spectacular. That, I think there's other industries that they will play a big role in. I think they will find their place in manufacturing and distribution in specific areas.
Right.
I'm not so sure it's inside of the places where robots play today. Maybe there's some assembly things that can happen, but overall I see that it's still going to be something that is purpose-built for a specific application.
Which would seem to feed back into what SK was saying about increasing the ROI, right? Because if you keep things the way they are and you simply just put a new automation tool right in the center of it, you're not really going to be able to go faster, right? I mean, not realistically speaking, you're not massively.
Yeah,
Anyway.
and I think
Whereas if you redo it with conveyors and everything else in purpose-built robotics, you're going to be able to go up.
And Americans have a specific way of looking at ROI as well. I know you guys all see this, but we have, you need a 1 year or a 2 year, maybe even a 3 year payback. But when you go to other regions, when you go to other markets, they're looking at 10-year paybacks, and they're just ripping it all out and rebuilding it again because they see it as the infrastructure that propels progress forward, right? So when these systems can last decades, and we're expecting a 3 year payback, you're not going to advance the adoption of this automation as fast as you could be realistically with the financing and the economics for robotics. So we need to kind of change our mind a little bit about how we look at the financing of these things as well.
Yeah.
It also, humanoids open up the possibility for other types of human beings to be involved in the manufacturing process. So much of manufacturing relies on strength, right? But if you can have a humanoid that is being managed by a disabled person who maybe doesn't have the strength but has the knowledge in order to be able to control that, then that opens up more career opportunities. So
Right.
that's how I kind of think about, kind of like just like AMRs and everything else, it does open up the opportunity for people who may not, in their father's or grandfather's generation thought about a manufacturing job because of the physicality of the job.
Right. Yeah. Yeah, I mean, we see this, and there's a lot of advances in exosystems and a lot of,
Exactly.
And so I'm starting to hear about that the AMR with the ARM solution is becoming, especially at the end of the line, is becoming something that people are really, really excited for. Most large installations have to use a large number of different types of robots for different application spaces, and interoperability has been a challenge, I think a barrier, getting these systems to talk to one another. You want to talk a little bit about that?
Yeah, I
Is
think
this going to be the year of the pedestal?
I think there's, similar to the cobot, there's spots where you can create kind of spot solutions and have something like that drive around and do work all day. Maybe you only receive stuff into the warehouse, for 2 hours in the morning, and then you need to go over here. You need to take these boxes and put it onto another pallet and put a label on it. You may be able to do some things like that, but you're exactly right. It's the scale of this that doesn't really go up, right? You need this massive fleet orchestration thing
Right.
all of a sudden with those types of solutions if you want to scale it up. So I think it works in some smaller areas. It'll work in small scale operations, but to scale that up would be really difficult. And I think ultimately you would actually change a lot about your infrastructure. And once you start to do that, well, was there a better option for you?
Right.
So that's
Might as
my
well
take.
just done the
Yep.
greenfield development again.
Right.
Reconfigure. Which brings us to the next point, which is great. And Suzy, you were talking a little bit ago about China. Now, which makes me think of the rest of Asia, which makes me think about, I'm sorry, you said Japan.
Japan,
I was thinking
yes.
about China.
Okay.
And obviously.
Well, that's a whole other area.
Yeah. So, I mean, we've been hearing for years about China being the leader on robotic adoption. But I'm curious, is that going to stay the case? Are we starting to see any momentum changes here in the US or in Europe as they're maybe trying to catch up? And if it does stay that way, what does that mean for the global manufacturing market? What does it mean for global manufacturing? China continues to run away, or is this like a third rail question where we?
Yeah, I think they will continue to accelerate. subsidized by the government in China. I think a lot of companies are starting there that are basically operating just off getting paid by the government to progress robotics forward, right? Without even really getting paid by their customers at the end of the day for what's realistic. So I think there's a lot of acceleration that'll still happen there. But there's other markets as well. I mean, you see South Korea is a massive adopter of robotics as well. I think both the US and Europe will propel forward, will advance, but at the same pace, we don't see that right now.
It's very hard, right? It's 12x what we do in, what they do in a month, we do it in a year, right?
Yeah.
And it's part of what you said, is subsidized heavily. It's also not only robotics, right? It's not in isolation, it's also the entire automation, the ecosystem, the fact that they purposely decided we're going to be the makers of things in the world. So we're going to train the people, we're going to have the infrastructure. It's the mentality, right? I can ask for a quote of a vendor in China, I get an answer in probably less than 8 hours. Sometimes overnight. I say, how are you awake? Like, why? How can you give me a quote and get it even faster than if I try to do with an American counterpart that may take 2 weeks?
Yeah, so I mean, just to dissect the problem into two different buckets to just see why China seems to be doing so well, right? So of course, in order for a manufacturer to deploy a robot, there are two parties, right? Robot makers and manufacturers, right? So, I mean, so if you look at it, US, where are our robot makers? There are hardly any robot makers in US, right? And it's not likely to change, in any time soon, right? Now, to all of our surprise, China actually produces more than 50% of the robot which they use themselves, right? So China is not only becoming world's biggest robot user, right? But China is also becoming world's biggest robot manufacturer, right? So once you take a look at government helping both sides of it, right? So they are just, making sure that their robot makers, other automation providers are also helping in building that ecosystem. And then their policies, which are then enabling manufacturers to use those robots, right? So that's the government side of it. But Chinese-made robot cost, when you look at it from the perspective of a Chinese manufacturer who's trying to deploy it, is very low. I mean, so we can't compete on those terms, right? So same robot which will cost you $50,000 in US if you were to get one of these Japanese or European robot, Chinese manufacturer will have access to a robot with comparable capability made in China at a fraction of that cost, right? So if you take a look at it, though they have attacked the problem on both fronts, not just that, okay, we are going to encourage more people to use robot, they also said we will build the entire ecosystem for making really cheap robots, right? So they attack both problems. So I don't think anytime we are going to see anybody in the world which is going to be able to compete with the cost of the Chinese-made robots, right? Even though, let's say tomorrow, government may start subsidizing everybody that they should buy more robot, but the cost of the robot is not going to go down in US anytime soon, right? So therefore, I mean, in the near term, we don't see, the growth in China slowing down, right?
100%. Nor us picking up. It sounds like we're catching up.
No, I wish we all had better news on that, right? I think, and a lot of it's been addressed by the panel. It's a challenge, I think, in the United States of the way that we're structured to be singularly focused on a small number of things, right? Certainly during the pandemic, we all said, whoa, we're not making enough things here in the United States. And that became very visible. But people don't even think about that anymore because it's not a crisis. And so we tend to operate more in crisis mode, I would say, as a country than in long-term strategic mode. I mean, if I look at, we're part of a set of organizations called Manufacturing USA that was created 10 years ago. We have our 10-year anniversary of all the institutes to try and have some impact on this problem. And we're trying, and we've got great members that are doing great work, but you put us up with like the Fraunhofer organizations in the work that they're doing in Germany, and we're like this much of the type of thing that they're doing there. And so we tend to, I always say we tend to throw a little bit of money at a lot of problems in the United States because we have such a diverse population and we have such a culture of invention, which is amazing and wonderful, but then we don't focus after that. So we're our own worst enemies sometimes. We have the ability, I always say, we invent all the robotic technology, but we have no major robotic companies in the United States. Like, we have a lot of great ones that are growing, but we don't, FANUC isn't here, Yaskawa's not here, KUKA's not here, right? ABB's not here, Universal's not here, right? All the major robotic suppliers in industrial automation are not US headquarters. I mean, they weren't started here. They're all from other countries. So
That's interesting you mentioned Germany, because that was the first thing that was coming to mind. Whether,
Right.
I mean, all the Asian nations tend to have a longer viewpoint, back to what Juan was talking about, right? And Josh, you were talking, we need to have a longer vision when it comes to payback and what our solution is. And then I was thinking, well, then there's cultural differences in some cases where certain, or maybe in socialist countries where the government works more in hand with commercial interests and does a lot of the Fraunhofer kind of
Right.
support and development. So I was wondering if maybe those, as a matter of fact, I really don't know what Germany's uptake is when compared per capita to China in terms of using robotics. You probably know one.
Yeah.
they're better than us. Better than us. So.
But it's also there is also better than us. But also, while robots is a proxy for automation, it's not just one-to-one. So there's a lot of automation that's not necessarily robotic.
Right.
So Germany is highly automated to the point that most of the tasks are automated. I think their strength is on the trades, right? They were able to train people and said, okay, you don't need to go to university, you can take the trades.
Right.
And that's institutionalized, is rewarded. So that education and workforce development is probably top worldwide.
Yeah.
So we also have that problem in the US, right? We
Yes.
have the stigma to nobody wants to work in manufacturing, so we don't have enough factories, not enough then motivation for robotics companies to do products only for the US. So it's a chicken and egg problem.
Chicken and egg
But
problem.
we need to
Yes.
reindustrialize. I mean, there is no
Yes.
future. We cannot continue to grow if we don't do it, right? So that's,
Well, at least we've given A3's board of directors a new list of agenda items. The same ones
There's always
they've been looking at
something
for
to
a long
work on,
time.
yes.
Cool.
But there are shining stars. I mean, we are not moving backwards. We're moving forward very slowly. That's what I would say.
We
And
need
I think,
glimpses. We,
yes.
we need shining stars to be able
Yes,
to say,
yeah.
oh, okay, that worked.
Well, and similar to the way we are in software development in the U.S., we have a lot of that trend here in North America, right? A lot of the software-enabled robotics companies are starting here in North America. So
Yes.
there's still a good trend there for us. Maybe not the
Absolutely.
makers or the adoption, but what we have the future, which is building the intelligence into these systems.
yes.
Yeah, I mean, entire AI revolution is being pioneered by
Yes, yeah.
US,
We are
right?
leading
So,
that.
yeah,
We are
so,
definitely leading
Right.
that, yes.
Okay, all right, cool. Because I really wasn't sure between U.S. and China right now in terms of AI, the number of GPUs that were developed or, and their
I think
processing
we are
ability.
definitely on the lead, right?
Beautiful.
With the interesting case also of France that has also companies like Anthropic that is also probably heads to heads to OpenAI. But for different reasons probably, right? Is the talent here, the software talent, as you were saying, is incredible, right?
Mhm.
Yeah, we are excellent at technology innovation,
Yeah.
maybe not as excellent at technology adoption. China's very good at technology adoption,
Right,
right?
right. And so much of that is government, regulatory, policy-based, macro level issues.
Are you noticing any other notable trends in industrial automation in general? For so long, automotive was huge, is still huge for robotics and automation, but beyond the automotive, like beyond the car floor, but beyond that and into some of these smaller or medium-sized enterprises, like, are you noticing anything interesting or notable with robots in general?
I would say a trend in kind of the distribution side of manufacturing is that smaller to medium-sized enterprises, smaller warehouses are able to adopt more robotics technology these days because of the software capability, the interoperability, the fleet systems that are out there. A lot of the QR code-based platforms that we've been kind of stuck because of the Kiva acquisition for a very long time and not able to deploy that technology. But now that's over and we're able to deploy that. and there's a lot more uptick in adoption of that type of technology inside of the distribution area, along with robotics as well. So I think you'll see more small warehouses that don't necessarily have all of the infrastructure adopt more flexible automation. That's what I've seen, at least. Yeah.
Yeah, it's very interesting to see and compare conferences. For example, you go to ProMap or Modex, and there's more warehouse and an automate, right? And see how also even the number of startups that target distribution instead of manufacturing. Because manufacturing, we put all under the same umbrella.
Right.
Factories look completely different. Well, warehouses have some commonalities, right? There are differences. A 3PL may be different than your own warehouse, but still they are more adapt to repeatability, therefore more adapt to automation. So I see a lot of very interesting startups in and new concepts for, like also for unloading trailers, right? In distribution. Less on manufacturing. I mean, I think SK is kind of the bright light one because that's really innovative and targeting manufacturing, but there are not that many. What I have seen in manufacturing is on the end of line, that was kind of not being looked at because that was more on the warehouse. Then it starts to propagate all these interesting new innovations in distribution centers. They start to be applied to the end of line part of manufacturing, so you see more AMRs, you see a lot more palletizing, DPAL, etc. And also machine vision, like more quality inspection is something that is also booming thanks to AI going back to.
This totally aligns with, we were just having, we had a recent other panel on machine vision, and that was one of the biggest things that they talked about. And we talked about the robotics machine vision relationship, you know. So by the way, so check out the machine vision panel when you get a chance.
Yeah, I would just have to second all that because, and in fact, people are becoming comfortable with it. Like they go to a restaurant and an AMR delivers their pizza, right? And they're like, that's like it doesn't scare them as maybe it would have 5 years ago. And so I think that just the technology itself and its capabilities, coupled with people who are like, no, yeah, that's okay. I expect something to be delivered to me by an AMR at some point in my life, right? And so they're comfortable with that. And it's easier to do, like you said. The processes are much more repeatable, so that's where we're seeing probably the most
AMR
movement.
Won't steal a piece of that pizza.
Yes, exactly.
We are beginning to see high mix manufacturers now beginning to take a serious look at robotics, right? So I mean, even aerospace companies, right? All leading aerospace companies are taking a very serious look at robotics and see how they can use it. So I mean, beyond automotive and electronics, I mean, there are marine industry, boat makers, right, yacht makers,
Very much so.
aerospace, right?
Yeah.
So many other sectors are beginning to take a serious look at robotics, what it can do for them, basically. So
That's
Well,
good to hear. Yeah, that's and that's a very difficult assembly
I was
task.
gonna say, we're seeing movement, and Juan helped us with this in the robotic sewing area. The whole apparel manufacturing, recycling. There's a lot of large organizations now have recycling goals, right? I'm a producer of high-end purses or high-end shoes. I have certain goals for sustainability that are put on me by my board that I need to meet. Well, who wants the job of ripping the laces out of a high-end pair of tennis shoes, right? So that you can recycle those materials. So we're definitely seeing movement in that whole apparel creation and apparel recycling as well.
That's interesting. That's interesting. How about ag tech, things outside of the production floor? Are you guys-
100%. I mean, it's driven